Hi everyone. Today we are going to be looking at some problem sets on laws of indices. Let us take a look at this question that says to simplify 4n squared raised to the power of 3. If you remember, one of the laws of indices that we talked about, which was the product power law, in this case, for us to be able to solve this, we will have to open up this bracket. And what do we need to do? We will have to distribute this power right here on each of these factors. Okay? And if you take note, you realize that 4 is same as 4 raised to the power of 1, right? So that means for me to be able to solve this or to simplify this, I would have something like this. 4 raised to the power of, power is 1, and it is also then raised to the power of 3. So I would say 1 times 3. That is going to be 3. So that is 4 raised to the power of 3. And also this is n, which is raised to the power of 2, which is then raised to the power of 3. Your product power law says that you should multiply these powers. So that means I'm going to have n raised to the power of 2 times 3. That is going to be 6. That means my final answer is going to be 4 raised to the power of 3 means 4 times 3, 4 times 4 times 4, which is 4 times 4 is 16. 16 times 4 is 64. So your final answer is 64 n raised to the power of 6. That is your final answer. Okay, let us take a look at another question. 2a cubed b squared all raised to the power of 2. Okay, let us take a look at this. We can also use the product power law right here. What do we need to do? 2 is same thing as 2 raised to power 1, right? I can bring this out to be 2 raised to the power of 1 times 2, which is 2. Because remember, all these factors right here are raised to the power of 2. Okay, so 1 times 2 is 2. A raised to the power of 3, which is then raised to the power of 2. What do you need to do? Product power law again says multiply the powers. Take note, guys, for a review on all these laws of indices, please check the link below. Okay, let's go ahead with this. A raised to the power of 3 gives you 3 times 2, that is 6, because you have a raised to the power of 3, everything raised to the power of 2 again. So I have a raised to the power of 6. B squared is also raised to the power of 2. That will be 2 times 2 is 4. I have b raised to the power of 4. Very good. Very good, guys. Then I have 2 raised to the power of 2, means you multiply 2 by itself twice. That is 2 times 2 is 4. A squared, a raised to the power 6. And then b raised to the power of 4. So that means my final answer is 4 a raised to the power of 6, b raised to the power of 4. Remember, what we did was to distribute this power right here on each of these factors. How do you do that? 2 means 2 raised to the power of 1. So you multiply out 1 times 2 gives us 2. That's 2 raised to the power 2. A raised to the power 3, which is then raised to the power of 2. You have to multiply out 3 times 2 gives you 6. That's a raised to the power of 6. b raised to the power of 2, which is then raised to the power of 2, means you would say 2 times 2 is 4. So I have b raised to the power of 4. Now 2 raised to the power of 2 gives me 4, because 2 times 2 is 4. A raised to the power of 6, and then b raised to the power of 4. Very good, guys. Let us look at more examples right here. Example 3. C raised to the power of 7 divided by c. Very good, guys. Very good. If you remember your division law says that if you have index notations as this with the same base, right, which is division, what you need to do is to subtract the powers. Okay, now if you take a look at this, the same base, that is c, is the same base. Okay, this has power of 7, because it is division. I will say minus. Now this c right here, if you just write c, it means c raised to the power of 1. There is an invisible 1 right there. Okay, that means I will then say minus 1, because this has an invisible 1 right here. So this is c, and c, they have the same base. I bring out c. This has 7 as the power, 7. Because it is division, we are going to subtract, and then 1, I bring 1 right here. So my final answer is going to be c, okay, raised to the power of 7 minus 1. That is 6. So my final answer is c raised to the power of 6. Very good, guys. Very good. Let us take a look at another example right here. Okay, example 4. 9a raised to the power of -5 times 4a raised to the power of 6. How do we solve this? Now, to solve this, all you have to do is to first of all multiply these numbers. This is 9 times 4. Okay, that gives me 36. Then if you look at this index notation, this is a raised to the power of -5 and a raised to the power of 6. They have the same base, common base, so I'll bring a out. Okay, so this is -5. I have -5. Now, because this is multiplication, in your multiplication law, it's going to become addition. We're going to do addition. Okay, and then this a is raised to the power of 6. I will have 6 right here. Again, what I did was to first of all multiply this 9. So I have 9 times 4 gives me 36. A and A, they have the same base. That means this notation right here and this one right here have the same base, which is A. So I bring that 1A. The power here is -5. I have -5. Now, because this is multiplication, so we are going to apply the multiplication law, which says I should add, that's plus, add the other power, 6. I have 6. So my final answer is going to give me 36 right here. A, -5 plus 6. That is going to give you 1. That is going to give you a +1. Okay, so that's 1. Then I'll have 36. A raised to the power of 1 is same thing as A. So my final answer is going to be 36A. I hope you all understand this fundamental concept. Okay guys, let us take a look at one more example right here. Example 5. Negative 4 a squared b all raised to the power of 3. All raised to the power of 3. Very easy guys, very easy. What we need to do right here is also to use our product power law, which says that this 3 will be distributed on each of these factors. Okay, and if you take a look at this is negative 4. Negative 4 is raised to the power of 3. Okay, so that means I have negative 4 times negative 4 times negative 4. That is what it means. If you take a look at this, negative 4 times negative 4, that is going to give me positive 16. Okay, if you remember your multiplication of numbers very well and signs, then I have this right here times negative 4 now. So if you now do positive 16 times negative 4, because positive times negative is going to give you negative right here, 16 times 4 gives you 64. Okay, so that means if I open up this one right here, it's going to give me negative 64. Remember, what we are trying to do right here is this cube is going to be distributed on each of these factors. And this is negative 4. You multiply it by itself 3 times. Negative 4 times negative 4 gives you positive 16 times another negative 4. That gives you negative 64. Okay, so that's 64. Then this is a squared raised to the power of 3. So you're going to multiply the power out. 2 times 3 will give you 6. So I have a raised to the power of 6. Okay, now this is b. If you just write b, it means b raised to the power of 1. Okay, so 1 times 3 is 3. So I have b raised to the power of 3. So my final answer is negative 64, a raised to the power of 6, and b raised to the power of 3. Alright guys, I will encourage you to go over this video several times until you are able to tell yourself or convince yourself that yes, I've understood this fundamental concept. I will see you in the next class, where we are going to be looking at more examples of problem sets in laws of indices. Alright guys, see you in the next class.